Okay, so welcome back to Unit 1 of Kinematics here for AP Physics 1. In this video, we're going to focus on acceleration. So what we've been talking about prior to this point is constant velocity. So our velocity is not going to change. But now we're going to talk about what happens when our velocity does change over time. Okay, so what happens is every time you start, stop, turn around, speed up, slow down, whatever you do, like in a car, walking, your velocity will change. Because remember, velocity depends on your direction. Okay, so there are two aspects to velocity: how fast you're moving and in what direction. So when I start, stop, right, I'm playing around with my how fast. If I speed up, slow down, I'm playing around with how fast. But if I turn around, I turn left, I turn right, then I'm playing around with my direction. Okay, now in physics, when an object changes its velocity, we say that it's undergoing an acceleration. Okay, now I do want to kind of bring this little caveat: is the word deceleration. A lot of times what happens is people will want to interchange this, say that this word means to speed up, or acceleration means to speed up, deceleration means to slow down. But in my classroom or in my setting, we do not use that word, because what that means is that acceleration is only to speed up. Acceleration is the entire process of speeding up, slowing down, turning, and all this, everything that's happening. Okay, so we call this the D word, right? So to us, it's a swear word. Okay, now there are three ways to accelerate an object, right? We can change the speed, right, which means we change the magnitude of the velocity. Okay, we can change the direction, which is very simple. We turn our steering wheel, right? Or we simply do both. So if I'm taking a turn in a car, I'm going to slow down and then turn the steering wheel. So I'm going to change both, okay? Now, in this class in AP Physics 1, a lot of what we're going to talk about is around what is called average acceleration. So again, this average does not mean mathematical acceleration. It means whole trip, okay? So again, I know there may be some confusion again around this word average, but again, in physics, average means whole trip, not simply doing the average of, the mathematical average. Okay, so now on cars, how do we change the speed? How do we, focus on the direction? Well, you have the gas pedal and brake pedal, right? So the brake pedal slows you down, right? And the gas pedal speeds you up. Now what happens is the gas pedal, and this is where cars come into play using these words. Now outside of this class, again, you can use that D word all you want, but when you come inside Mr. Londot's world of physics, the D word is not acceptable. So the gas pedal is actually called the accelerator, and the brake pedal is actually called the de-worderator. Okay, and then how do we change the direction? Well, simple. We have a steering wheel, right? So this will change our speed, and then this changes our direction. Okay. Now, acceleration is very important for car people who really enjoy like working with cars or reading about cars. So this is typically what happens. You have an advertisement that says that a car can go from 0 to 26.8 meters per second, which is the SI equivalent to miles per hour, right? The 60 mile per hour. All right, and they can do it in 6.2 seconds. What is the average acceleration of the car? Okay, then part B here, a drag racer deploys a parachute and slows down from 130 meters per second to 45 meters per second in 3 seconds. What is the acceleration of the racer? Okay, so we didn't quite talk about the equation, but the way to think about it is acceleration is the rate at which velocity changes. So just like when we talked about velocity is the rate at which displacement changes, we have this delta V over delta T, right? And so if we look at the first part A, so we say acceleration is delta V over delta T. So it's change in velocity over change in time. So we're going to do 26.8 minus 0 over 6.2 seconds, right? And so it's simply 26.8, because our initial velocity is 0, divided by, if I put the divide by symbol, 6.2, And so that tells me that it has an average acceleration of plus 4.3 meters per second squared. Okay, so the SI unit for acceleration, right, is meters per second squared. It doesn't seem like much, but you have to remember this is in meters per second, not necessarily miles per hour. I mean, we're talking nearly 10 miles per hour per second. If you do kind of using the miles per hour calculation. All right, part B says now a drag racer deploys the parachute and slows down from 130 to 45 in 3 seconds. Was the acceleration of the racer? So we use our delta V over delta T. So it's going to be 130 minus 45 over 3. So plug into our calculator, 130 over 45, or excuse me, 130 minus 45 divided by 3. So it tells us that they're going to have, oh, I got these backwards. I apologize. So it should be 45 minus 130, right, over 3 because it's slowing down. And so that should be a negative 28.3 meters per second squared. So something that you see when you speed up, your acceleration is positive, and then when you slow down, your acceleration is negative. Okay, it's just a simple way to check. Okay, now again, we're going to keep building on our knowledge, and so now we're going to add this acceleration piece by looking at some more graphs.